Okay, boys, bracing. So it says calculate the length of this brace. Now, actually, let's read the question first. I'm getting a little bit ahead of myself. So guys, the frame at right has the dimensions shown. It's proposed to put a brace across the diagonal of the frame. Now guys, whenever, like you might be given a type of question where you're given just like the dimension, like the dimension of the room, and it would say, find the longest brace possible or something like that. If you're asked to find the longest brace possible, the first thing you test is from corner to corner. Okay, so corner to corner is the first thing you test. Okay, and then you check that. You check it by getting the angle in here. Okay, the angle between the brace and the floor. If that is smaller than 37 degrees, then what you'll do is you'll use 37 degrees, because 37 degrees will give you the longest brace. The reason you check the diagonal first is because the longest brace may be bigger than 37 degrees depending on the length of the wall. So always, if you're asked to find the longest brace, always check the corner to corner first. And if that doesn't work, then you go with 37 degrees. Okay, so having said that, let's just finish this up. Calculate the length of the brace. Well guys, we can just use Pythagoras here. Okay? Now I know it's going to be a little bit weird because in Pythagoras we label A, B, and C, and then we're going to have to do some trig in a little bit, and that will be SOHCAHTOA. So we're going to be labeling the sides, then we'll label the sides O, A, and H. But anyway, so A, calculate the length. So the length is going to equal, let's see here, well it's going to be the square root of 6 squared plus 2.4 squared. Okay guys, because this is C, this is our right angle, okay, so this is C, A, and B. It doesn't really matter A and B, the order. Okay, so now we're going to use that to find the length. Okay, so it's going to be 6.642. And guys, the reason why I'm rounding it to 3 decimal places is that will give me millimeters. And guys, if I rounded it to 1 decimal place, okay, guys, I might be off like it could be off like 10 centimeters. Okay, so just round to 3 decimal places. Okay, because we want to, when we make the cut, we want it to fit. Okay, so 3 decimal places, or just work in millimeters. Okay, now it says show that the angle which brace makes with the base of the frame is not within industry standards. Okay, so guys, basically we got to find theta here. Okay, we got to find that angle. Okay, so now we're going to remember, guys, SOHCAHTOA. Okay, we got to find an angle using, SOHCAHTOA. Okay, so let's label these sides up. Okay, so this side is the opposite, this side is the adjacent, this side is the hypotenuse, but we're not going to be using the hypotenuse, but we'll label it anyway. Okay, so we have O and A involved, so it's going to be tan. So we know that tan theta equals O over A, because that's what SOHCAHTOA tells us. Okay, so we know that theta is going to be tan -1, and we're going to sub in our values for O and A of 2.4 over 6. Okay, we're going to put that into our calculator. And guys, make sure you're in degrees, angle degrees. Okay, so guys, what I did to check that, I went Shift menu and made sure that angle was in degrees. Okay, so we're going to go Shift tan. Okay, and I'm just going to put a bracket. I'm going to go like this, so 2.4 over 6. Guys, I need to close the bracket. Okay, and that gives me 22.8 degrees. Okay, well outside, what was it? 21.8 degrees. Well outside the industry standards. Okay, that brace is too long. Okay, now it says find the length of the longest brace that does comply. Well, guys, we know that the brace, I know it's a terrible drawing. Sorry, guys. Okay, that the brace, it has to go 2.4 high. Okay, but the longest brace is going to give us some dimension here. Okay, but it's going to give us 37 degrees in there. Okay. Now, it wants us to find the length. Okay, well, guys, it has to be 2.4 tall here, and it has to be 37 degrees here. So we can find that length using trig. Okay, so what we have is we have a triangle that's 2.4 and 37 degrees. Okay, so and this would be x. Okay, so let's label our sides up. Okay, so this is the opposite. This is the hypotenuse. This is the adjacent. Okay, so what sides are involved? Okay, we've got H and O, which means we're going to be using sine. Okay, so let's do that. Okay, so C, sine theta equals O over H. Theta equals sine -1, and then here O is 2.4. Oh shoot, guys, I'm silly. Okay, I got ahead of myself. The mistake I made there, guys, is I've been thinking about solving for angles, guys, and then I just got ahead of myself. So, guys, I have a theta, and that's 37 degrees. Okay, I have an opposite that is 2.4. I don't have an x. Okay, my hypotenuse is x. Okay, guys, so remember, when the unknown's on the bottom, how do we solve for it? Well, we do the swap when x is on the bottom. So x equals 2.4 over sine of 37 degrees. Guys, I'm just going to bring this up here. Let's just find that. So we've got 2.4 over sine 37. Okay, and that's going to go as 3.988 meters. Okay, so the longest brace we can have will be 3.988 meters long, and it will make an angle of 37 degrees with the bottom frame, or the ground. Alrighty. Okay. Now, guys, we got another framing question. This one involves avoiding a window. Now, guys, this type of question is really good because you have to show your skills in a lot of different ways. So it could be a very good question to test you on. So let's have a look. So, guys, basically we know we have to be between 37 degrees and 53 degrees. Again, we can't pass through a window. Okay? Now, that means we could basically do two things here that we might have to check both of them. Okay? So we could go from this bottom corner to just missing this, and then see, make sure, two things, make sure this angle's okay, and then make sure that it's going to reach the ceiling before it runs out of room going this way. The other one we could try is one that starts here, goes here, okay? Okay, and then obviously extends all the way up to the ceiling. Okay? So we've basically got two possibilities here. Okay. So, guys, what I'm going to do is I'm going to check the angle on both of them. Okay? So brace 1, I'm going to do in green. So brace 1, that's the first possibility to give us the longest brace. Okay? Because we want to calculate the longest brace. Okay, so just to check the angle, we know that's got to go 2,500 mils. And guys, if it doesn't give a dimension, we know it's in millimeters. Okay, but it's going to make the triangle is going to go from here to here. Okay, we don't know right now, because we don't know the angle, we don't know how far it's going to extend, and we don't know, we don't know how far it's going to extend. Okay, so right now we're just going to focus on basically this triangle right here, from the bottom corner up to the corner of the window. And what height is that? Well, if we look here, okay, we got 2400 here and 1200 there. Okay, which means this distance here has to be 1200. Okay, so 1200. Okay, so we're going to go up this way. I'm going to check theta there. Okay, so that theta there must be between 37 and 53 degrees. Okay, so guys, remember we have SOHCAHTOA. Okay, so we want to find theta. So we have the opposite and the adjacent. So guys, opposite adjacent is tan. Okay, so we have tan theta equals O over A. Okay, so theta is going to be tan -1 of 1200 over 2500. Okay, let's see what angle that gives us. Okay, oops, what happened there? Alright, shift tan. Hopefully I can remember these numbers. Was it 1200? Yeah, over 2500. Okay, and that gives us 25.4 degrees. Okay, so 25.4 degrees. Okay, so guys, basically I know that I can't do this brace here. Okay, now what I do know, guys, is I can put a 37 degree brace somewhere in here. So I'm actually not gonna check this, okay, because what I can do is I can start from here. I'm going to go down at a different angle here, and I'm going to force it to be 37 degrees. Okay, so I'm going to make that 37 degrees there. Okay, it's going to miss it. Okay, then it's going to go up to here. Okay, guys, and if you read the question, all it's asking for is the angle that the longest brace will make. Oh, sorry. It does say calculate the length of the longest brace. Okay, and it says what angle does it make? Well, we know it makes 37 degrees. Okay, because 37 degrees is the longest brace possible. Okay, and we know that it's possible because it's 25 degrees from here to here. Okay, and then the further I come in this way, the bigger the angle gets. Okay, and I can get a 37 degree angle brace in here, no problem. Okay, so the length of the brace. Okay, so basically, guys, we have a triangle. Okay, this is the brace. Okay, this is 37 degrees. Okay, we know that this is 2400. It's got to go all the way to the top. Okay, so if we label this up, okay, so this is X. That's what we're trying to find. So that's X. Okay, that means this is the opposite. This is the hypotenuse. Okay, so we're going to use sine. Okay, so sine theta equals O over H. Okay, we have a value for theta, which is 37 degrees. We have a value for O, which is 2400. Okay, and we're solving for X. Just like the last question, guys, we're going to swap those two. So X equals 2400 over the sine of 37 degrees. Okay, and that's going to be okay, 3,988 millimeters. Okay, so that is the length of the longest brace there. Alrighty guys, hopefully that cleared some things up.